So it's essential at this point in time that you are aware of how to do your normal naming of hydrocarbons that are alkanes, alkenes, and alkynes. So after the last video, you should have completed Skill 2. If you haven't completed Skill 2, this video will probably not make a lot of sense to you. Okay. So now that you have completed the last video, we're now going to move on and talk about the next table that you're going to need. And that table is going to be the one that says Organic Functional Groups, which is located on page 8 of your reference table, and it is Table R. So one thing I want you to be familiar with is how to use this table. Okay, so I'm going to back out a little bit and do my best to kind of have what's going on maybe down below. So let's take a look. If you're using Table R from your chemistry reference tables, work with a partner, take some time. You want to be able to really understand how these tables are created. Okay? So we have our class of compounds on the left, okay, meaning that if we were to call it a group of compounds, it would be considered halides or alcohols or ketones. There's a specific group, and we call it a functional group, that is going to be found throughout. So an alcohol will always have an OH, or an ether will always have an oxygen between two hydrocarbons. The general formula is R is bonded to some kind of X. And in this case, the X represents any of the halogens which are found in your group 17. Okay. And again, R is representing a group of atoms. More likely than not, they're going to be a carbon and hydrogen chain. And luckily, they do give you an example. They give you an example of the molecular formula as well as how to name it. And the naming part can be a little bit tricky, and hopefully throughout the course of going through these functional groups, you'll be able to better assist with what these twos mean and what these ones mean when we draw certain components to this. Okay. So once you've kind of looked through this, as we've done, we're going to locate each class of compounds as we go. So let's start with the halides, and then this is going to be broken up into multiple different videos just because there's 9 different functional groups that you should be able to understand how it works. So most of this information can be gathered from your reference table. There are 4 elements from the functional groups of the halides. Okay, that's going to be, as it says, fluorine, chlorine, bromine, and iodine. And once you find these elements, we look at the periodic table, and it turns out they all belong to group 17. And we know that in group 17, we have 7 electrons. So in the general formula, when we're writing this to fit onto some hydrocarbon chain, that X is going to represent one of those 4 elements and wherever we put it. So looking at the example that's given in your table R, let's break this down even further. Okay. So you need to be able to draw, if not name, these formulas. So let's do that. The first thing you do is you draw the carbon-hydrogen chain in order from the left to the right. So we have C with 3 H's. Check. I have a carbon with an H and a Cl. And then I have a carbon with 3 H's. H, H, H. So what you do, just so that you can really focus in on the functional group, is let's put a box around the chlorine atom. Let's kind of keep that by itself. And another thing that we want to do is we want to circle the carbon chain, because this is how we named the carbon originally when we were going over skill 2. So what you do, left to right, right to left, whatever makes the least amount of numbers, is you label them. So 1, 2, 3. Okay. How many carbons are in this chain? 3 of them. What type of bonds are in this chain? They're all single, so we're going to call them single bonds. Why is this named propane? Well, if we didn't have this chlorine, we would call it propane. It's an alkane with 3 carbons, and that prefix is pro. Okay. But now we're going to take into account that box, that functional group. Okay. You drew it. What element is it? It's chlorine. Okay. How is it represented in the name? So taking a look back at the name, you have to put the name of what you have in front. So it's going to be chloro. And another thing that's here is the 2. So you can surmise, well, wait a minute, number 2, that means it's coming off the second carbon. So it's 2-chloropropane. And you can see that, how it's represented by the name. So the number is going to represent the number carbon it's on. The prefix before the hydrocarbon is going to be the halogen or the halide. And this is going to be the hydrocarbon name. So that's the fit. So let's take that knowledge and apply it to drawing something else. So step by step, let's do it. We have hexane. Hex, the prefix for hex is 6. So 1, 2, 3, 4, 5, 6. All single bonds because it's ane. Now I'm going to label them. 1, 2, 3, 4, 5, 6. On the third carbon, this one, we're going to add bromo. Of the 4 halides, bromo is Br. And again, everything else that's attached are hydrogen ions. Excuse me, hydrogen elements. And again, justify with your drawing if it looks like this. Why is it called that? Because the 3 stands for the number carbon that the bromine is on, and the hydrocarbon chain is hexane. Hope this helps.